Welcome back to problem 11, the last part. This requires some drawings, so I took a break to make these drawings. All right, we need to figure out the entire distance traveled in the first 8 seconds. All right, now this requires a little bit of thought. Recall our velocity. Velocity is derivative of position. We calculated the velocity to be 3t squared minus 18t plus 15. Setting this to 0 gave us t equals 5 or 1. Alright, now 3t squared minus 18t plus 15 factors like this. 3 comes out common, t squared minus 6t plus 5 factors further. Okay, that's how we got the 1 and the 5. All right. Moreover, this is a quadratic. In other words, the graph has to be a parabola. So I took some time to draw this. In the exam, you will have to draw the parabolas. Now, how did I get this drawing? Notice, all you need are the horizontal intercepts. This gave you t equals 1. This gave you t equals 5. So you know these are the intercepts. Secondly, you know that because this is degree 2, it's a parabola. Positive 3 means it opens upwards. That's all. That's all it took. Now, what's the purpose of all this? Notice, from 0 to 1, velocity is above. So, v of t is greater than 0 from 0 to 1. All right, the next step, v of t is negative, it's below the t-axis from 1 to 5. v of t is negative, less than 0 means negative, from 1 to 5. Okay, after 5, v of t is positive. All right, what does that mean? Velocity is greater than 0, that is, velocity is positive, means position, particle is moving forward. All right, what does velocity negative means? It means particle is moving backward. Lastly, velocity is positive means particle is moving forward again, forever now. All right. So, in other words, I need to know the positions. So, the important numbers to start with are time is 0, time is 1, time is 5, and time is 8. 0 because that's when my particle starts moving, right? Time 0. Why 1 and 5? Because those were the times when velocity was 0. You remember? And then 8 because that's part of the question during the first 8 seconds. So I have taken the trouble of calculating these numbers. What are these numbers? These numbers come from the formula. Let me write it down. S of t equals t to the power 3 minus 9t squared plus 15t plus 5. Where did this formula come from? That was our question, right? That was your position. So now plug in t equals 0, then 1. So starting from time t equals 0, then 1, then 5, and then 8. 8 because that's part of the question, first 8 seconds. 0, 1, 5, and 8. These 4 numbers you need to plug in. When you plug in these numbers in your position function, you get these values. When t is 0, I get value 5. When t is 1, I get value 12. You will have to plug it in and check for yourself. When t is 5, I get value negative 20, mind you. That's why it's written behind. And lastly, when t is 8, I get positive 61. Plug in these values, make sure I'm correct. All right. Now, how does the position start moving? So here, I need to draw some pictures, right? So I will use my pencil. I'm starting here. I'm moving forward. How do I know I'm moving forward? Because from T0 to T1, particle is moving forward. Okay. 1 to 5, particle is moving backward. Oops, my drawing is off. Particle has moved backward. And then after 5, particle moves forward. All right. So, sorry about that twist. My hands are a bit shaky. All right. So this gave you a picture of how the particle is going. First, it moves forward for 1 second. Then from 1 second to 5 seconds, it moves back. And 5 seconds onwards, it moves front. Okay, keeps going. All right, we are done with that. So the question is, what is the distance traveled? From here to here, it went from position 5 to position 12. So this distance is 7 plus. Now, from position 12, it has to go to position negative 20. In other words, all of 12 has to go back, 0, and then negative 20. So 12 and 20 more. 12 and 20 more is 32 plus. Now, from negative 20 to 61 on the number line. So all of 20 until 0. 0 should be somewhere here. All of 20 until 0 and then 61. So 20 and 61. All of this. I hope this is clear. Check your work. We are done. All right. So this completes problem 11. See you so long until the next problem.